Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to continue with trig functions. I want, before looking at, I don't know if it contains that or not, but before taking a worksheet, I want to go over some what we call trig identities. I hit my hand and it hurts so much. I'm sorry. Okay, so the first identity, which I told you, it's not really an identity, it's a special case of an identity, which is sine square of any angle, let's say theta plus cosine square of theta equals 1, right? But out of this, we have other uh, other identities. For example, suppose I divide this whole equation by cosine square. Cosine square. So sine over cosine is tan. So sine square over cosine square is tan square theta. Plus cosine square over cosine square is 1. 1 over cosine square is secant square. So it's the same identity, but it's derived from it. We cannot call them really two identities. If instead I divide by cosine instead of by sine instead of cosine, sine square over sine square is 1, so I divide by sine square. Cosine over sine is cotan, so cosine square over sine square is cotan square theta. And 1 over 1 over sine square is cosecant square theta. So these three are really one identity, but we are simply dividing and multiplying, so we didn't do anything. Okay, now we also have two more rules that we need to talk about. They're not identity things, but suppose I have sine of alpha plus beta. Two angles, any two angles. You can say A plus B if you don't like Greek letters, but it's the same thing. And I'm going to say plus or minus. You will see why. I say this equals sine alpha cosine beta plus or minus cosine alpha sine beta. Okay? So sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And sine alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. Likewise for cosine, cosine alpha plus or minus beta. Here you get cosine alpha cosine beta minus plus. So it's the opposite. If this is plus, you subtract. If it's minus, you add. Cosine, I'm sorry, sine alpha sine beta. Okay? Then the last one would be tan alpha plus or minus beta equals tan alpha tan, I'm sorry, plus or minus, no, tan alpha tan beta divided by 1 minus plus. So tan alpha, what did I say? I said plus or minus, plus or minus. And then when you divide, you do it backwards. And you can remember it as that sine is the numerator for the tan. Sine is the numerator, cosine is the denominator. Sine, the signs follow the same. And for cosine, they switch. Let's take some examples we know. So for example, if I want to say sine 60, I know sine 60 is root 3 over 2. So if I substitute here with this is 30 and this is 30, I say sine 30 is 1/2 times cosine 30, which is root 3 over 2, plus cosine root 3 over 2 times sine 1/2. If I factor out the 1/2, I get root 3 over 2 plus root 3 over 2, that's root 3. So you get root 3 over 2. For the cosine, suppose I know that cosine 0 is 1. So let's say cosine 60 and 60. And I'm going to say cosine 0, which is, in this case, I'm going to say 60 minus 60. It would be cosine 60, which is 1/2, times cosine 60, which is another 1/2, because both of them are 60, plus, because when they subtract, you add here, sine 60, which is √3/2, times sine 60, which is √3/2. You get 1/4 plus 3/4 equals 1. Yes, cosine 0 is 1. Finally, if I want to get tan 30, which I'm going to write as 60 minus 30. I know that tan 30 is √3/3, or 1/√3, doesn't matter. So I say tan, the first one, which is √3, minus tan 30, which is √3/3, divided by 1 plus, because I'm subtracting here, so I make it plus in the denominator, √3 times √3/3. Okay? So the numerator is 3√3 minus √3/3. So it's 2√3/3. The denominator is 3 plus 3. You see, if you make this 3/3, so the denominator has a denominator of 3. 3 times 1 is 3, and √3 times √3 is another 3. So you get 6/3, or 2. So you get 2√3/2 over 6, I'm sorry, because the 3 and the 3 cancel. I was going to say 2√3/3, everything over 2, but then, and then the 2 and the 3 simplify to √3/3, which we said is the answer. So these three rules work for adding or subtracting sines, cosines, or tans. Then remember, I used 30 and 30 and 60 and 60, which means I can write another set of equations for the double degree formula, twice alpha. I can think of that as alpha plus alpha, right? So it would be sine alpha, cosine alpha, plus cosine alpha, sine alpha. It's the same quantity twice. So it's 2 sine alpha, cosine alpha. That's the first rule for the double. How about the cosine? Cosine 2 alpha. It means alpha plus alpha, right? So that becomes cosine alpha times cosine alpha, or cosine square alpha. And because I'm adding, I subtract. Plus is with minus. Sine alpha times another sine alpha, so it's sine square alpha. This can be written in 3 different ways, like this, or I can call this, remember from this equation, cosine square theta equals 1 minus sine square theta, right? So if I write this as 1 minus sine square theta, minus another sine square theta, so that becomes 2. Or I can use this as 1 minus cosine theta, right? So if you do the math, you will get 2 cosine square theta minus 1. These 3 can be used interchangeably when we do the cosine of twice an angle. And finally, tan 2θ, or 2 alpha. It's tan alpha plus tan alpha, so 2 tan alpha. And here I used the alpha, and then I changed them into theta because I was looking at theta. I'm sorry. This should be alpha, of course, but you get the point, right? Divided by 1, when you do alpha plus alpha, it means subtract minus tan square alpha. And these are called the double angle formula. I can also use the half angle formula. What? Yeah. Do you see that from this equation? From this equation, I see that if I add two sine square alpha to both sides, and then subtract cosine 2 alpha from both sides, I will get 2 sine square alpha, when I move it to the left, equals 1 minus cosine 2 alpha. Now, instead of using alpha and 2 alpha, I use 1/2 theta and theta. It's the same thing. This is twice that. And then divide both sides by 2. So I get sine square theta over 2 equals 1 minus cos theta over 2. And I can do the cosine also from this equation. Cosine square theta over 2, half an angle, equals, when I move the 1 to the other side, it becomes 1 plus cos theta over 2. And if you want tan square, well, you can use this or you can divide this by that, by the way. The 2's cancel and you get tan square theta over 2 if you want. I don't think you will need it, but you will get 1 minus cos theta over 1 plus cos theta. And these are pretty much everything you will need in this course, and more even. I don't think you will need those. So let's go to work because I don't want to waste more time. I don't know, we have too many problems there. Oh, 29. I don't think we can do all of those. We'll see. That's proving identities. Do I have another? I probably have another. So maybe I'll take some of this and some of that. First of all, yeah, I think let's go to looking at coterminal angles and stuff like we did before. I think the first part is easy. Find a positive and a negative coterminal angle for each given angle. If it has to be the coterminal, you either add 360 or subtract 360. So if I pick this, for example, I add 360, so I get 525 degrees. And if I subtract 360, I get negative 195 degrees. Let's check. Let's pick sine or cosine, doesn't matter. So sine 165. Oops. Am I using? Oh, yeah, I'm still using degrees. What about sine 525? Same value. So how about sine negative 195? Same value. Okay, so once you add 360 or subtract 360, it's ridiculous. Here you add or subtract 2 pi. So this is 3 pi over 2. If I add 2 pi is 4 pi over 2, so I get 7 pi over 2. If I subtract 2 pi, I get negative pi over 2. And I think the rest is the same, so I'm not going to waste your time on that. State if they are coterminal. All what you have to do is to subtract. This is tricky, by the way, because if you subtract negative 380 from 20, you get 400, so they are not. If you subtract this from that, you get 540, which is not a multiple of 360. When you subtract this from that, you get 360, so that's fine. If you subtract these, the difference is only 100, so we know it's not. Very quick. Now, they want you to calculate cosine theta. Cosine is adjacent over hypotenuse, but I don't know the hypotenuse. I know that if I have a right triangle, I can use the Pythagorean theorem and say the hypotenuse, let me call it h. H square is 5 square plus 12 square equals 25 plus 144 equals 169. So this is 13. So the cosine of theta is adjacent over hypotenuse. Cosine theta equals 12 over 13. 9, 12. So this is 15. Multiples of 3, 4, 5. This is the common Pythagorean theorem, right? You multiply this by 3, you multiply this by 3, so you multiply that by 3. And tangent of that is opposite over adjacent. Tan theta equals 9 over 12 equals 3 over 4 or 0.75. And the rest are the same. Convert each degree into radian, multiply by pi over 180 degrees. Okay, this is 4 times 45. So if I divide by 4, I get 45 degrees. If I divide by 5, I get 45 degrees. I'm sorry, we divide by, no, I should divide by 5. So I get 36 degrees, and I divide by 5, I get 45. I divide by 9 again. This is 5 and that's 4, so I get 5 pi over 4. I want to change that, so negative 17 over 12 pi. You multiply by 180 over pi. The pi's cancel. This over that is 15. I'm sorry, 15. 15 times 17 is 255, so negative 255 degrees. You can check with the calculator, but these are easy numbers to multiply and divide. I didn't want to waste time on that. So let's go back to the identities, because these are like coterminal. We could have done them last time, but I really didn't want it to be very long, and I see 2 more sessions before we finish, so I don't want to waste your time. Again, I keep repeating, I have a whole playlist of trig. You can visit those and, you know, complement with some problems from there. The expression 1 minus, every time you see 1 minus sine square or 1 minus cosine square, think of the identity. If I subtract sine square from both sides, I get 1 minus sine square equals cosine square. So this is cosine square alpha A over 2 cosine A. Unless A is 90 degrees, I can simplify. Be careful here. Again, here we give you a generic form, right? But in order to be really accurate, they should tell you in the problem this expression, and then next to it, it is say A is not a multiple of 90 plus 2. Well, we'll talk about that later. But if it's not multiple of n, 90n, where n is an odd number, so meaning if it's 90 or 270 or 540 or 450, I'm sorry, then that would be, no, it does. In this case, it doesn't matter. But you see, if this is 90, cosine square 90 is 0, and cosine 90 is 0, and you cannot divide 0 by 0. But here we assume the general case. I can simplify the square with the cosine, and you get cosine A over 2, which is number 2. This is similar, so I'm going to skip it. This is similar, I'm going to skip it. Sine A is k. Then the value of the expression sine A times cosine A times tan A is equivalent to what? Well, sine A is k. Times cosine A, notice I'm not going to worry about what cosine A is, times tan A, but tan A is sine over cosine, and sine is k, so k over cosine of A. These cancel even if I don't know their magnitude, and I get k squared, which is number 4. Sine square over tan, sine square over tan, meaning multiplying by the reciprocal of tan, which is cotan, meaning by cosine over sine. The square cancels and you get sine A cosine A. By the way, sine A cosine A, they can make it harder, but I'm glad they didn't. They can say equals 1/2 sin²A. Do you know what's sin²A? It's 2 sine A cosine A. And this is only sine A cosine A, not 2. So it's 1/2 of that. But I'm glad they didn't do that. The answer is 2. Uh, okay, let's go. So I have another page. Let's look at this page. So let's pick few problems. 16, 19. No, this is easy. Or let's try to do that. Do that. 25, 28, whatever. Okay. Let's look at number 16. For all values of theta for which the expressions are defined, prove the identity. That's nice. For which the expressions are defined. So nobody would say, what if this is whatever, 0 or infinity or whatever. No, they say, excluding those, assume they won't happen. How can you prove the left-hand side? The right-hand side is cotan. Okay, so I know that I need to have cosine on the top and sine at the bottom. First of all, I have tan. You can simplify it as sine theta over cosine theta. That's the numerator. Times cosecant, but cosecant is 1 over sine square, right? Cosecant square is 1 over sine. And I know that this is secant square. You know that. This is secant square, but secant square is 1 over cosine square. You can do that in multiple steps. I'm just trying to save time. Now, when you divide by a fraction, you multiply by its reciprocal. But before doing that, the sine and the sine cancel. Okay? And I get this equals 1 over sine theta cosine theta multiplied by cosine square theta. The square goes with the cosine, so you end up with cosine over sine equals cotan theta, and that proves this. That's number 60. I said let's go to number what? 19 after that. Following identity, prove it. Tan theta over cotan theta plus 1 equals secant square theta. You should know that tan over cotan is tan square because the cotan is the reciprocal of tan. But if you don't see it, you can say sine theta over cosine theta divided by, so I'm going to skip a step and multiply it by the reciprocal of cotan, which is tan. So by sine square theta, oh, I'm sorry, sine y square, sine theta over cosine theta plus 1. Okay, so sine square over cosine square plus 1 equals what? I know that this is tan square and tan square plus 1 is secant square, or I can take a common denominator if you wish. Cosine square theta, both are correct. Sine square theta plus cosine square theta equals, because I took a common denominator. Sine square plus cosine square is 1, so 1 over cosine square theta, but 1 over cosine is secant, so this is secant square theta. Easy. Number 22. They say for all values of theta for which the expressions are defined, prove the following is an identity. Cos theta sine theta plus cos theta divided by tan theta plus cotan theta equals 2 sin² θ minus 1. Okay, so first I'm going to write them as, for example, I can take, well, it doesn't matter. I can leave it as it is so far. Sin² plus cos²θ. And then when I go down, I'm going to say sin² over cos² plus cos² over sin². Cos² sin² plus cos² over. When I take a uh, common denominator, well, I think this is sine, not. So if I take sin² cos² as a common denominator, I get sin²θ plus cosine²θ. This is 1. And when I do the reciprocal, look what happened. The numerator, I'm going to factor out the cos²θ. So I get sin² plus 1. And then I'm going to multiply by sin² cos²θ, right? Because I multiply by that and I divide by this, but this equals 1. Okay. Did I do it correctly? I think I did. Oh, sine plus 1. Yeah, sine plus 1 times cosine. And then I multiplied by that. Okay. So the right-hand side, by the way, is negative cosine 2θ. Did I do it correctly? Would have been easier, I think. And this is sine squared plus cosine squared, so you get 1. So, okay, how do we get this from that? If I distribute the sign, so I get sin²θ cosine²θ, which when I multiply this, by this, and by that, plus sin² cosine²θ. Should I do this as 1 minus sine square? No. Oh, where did I get the right hand side? I confused 22 with 23. I combined them to, oh God. He said that doesn't make any sense. I wanted to finish quickly. Okay, again, it says cos² sin². I got that signs, I was doing 21, not 22, and then I confused the numerator with, it's like, oh my God. Sorry, guys, just ignore this part. I'm not going to edit anything. I really don't have time. Okay. So we want to prove that, right? So I can, first of all, I can, oh, this is, see, I did it again. And there is plus cos theta here. Okay, so I can split this into two pieces, right? Because there is a plus. So I can say cos theta sine theta over cos square theta plus cos theta over cos square theta. And then I simplify. It's very easy. I will divide this and this with that. So the left-hand side is sine over cosine, which is tan. The second term is 1 over cosine, which is secant. So that's easy. Number 25. For all values of theta for which the expressions are defined, prove the following. 2 cosecant square theta equals 1 over 1 plus cos theta plus 1 over 1 minus cos theta. Once you see two different denominators, you take a common denominator. The common denominator, if I want to work the right-hand side and prove it's to the left, instead of proving the left is equal to the right. It's easier, I think, in this case. So the denominator would be square of the first minus square of the second. Right? But 1 minus cosine square is secant square. I'm sorry, is sine square. And 1 over sine is cosecant. Where is the 2? Oh, when I took the common denominator, I didn't do that. 1 minus cos theta plus 1 plus cos theta. So cos theta minus cos theta cancel and you get 2. You see, when I divide this by that, I do the cross. So I say 1 minus cosine theta times 1 plus 1 times 1 plus cosine theta. So the negative cosine and positive cosine cancel, and 1 plus 1 is 2. 1 over sine is cosecant, so 1 over sine square is cosecant square times 2 is 2 cosecant square theta. And that's done. The last one, oh, it took more than half an hour, but not much. Okay, last one, number 28. For all values of theta for which the expressions are defined, prove that the following is an identity. Cos theta times cos theta plus 1 plus sine square theta equals, I want it to be sine of theta plus tan of theta over tan of theta. So if I look at the left-hand side and I distribute that, I get cos square theta plus cos theta plus sine square theta equals. These two add up to 1, so I get 1 plus cos theta. I can stop there and then go to the right-hand side and prove that it's 1 plus cos theta. That's the easiest way to do it. So I'm going to go to the right-hand side and say, this is sine theta plus sine theta over cos theta divided by sine theta over cos theta. I can take a common denominator of the numerator, so that would be sine theta cosine theta plus sine theta divided by, and then I can multiply by the reciprocal. So I'm going to multiply by sine theta and divide by cosine theta. Okay? Now, I multiply the numerator. So because I have two terms, sine times sine, I get sine square theta sine plus tan over tan, right? Yeah. Okay, sine square theta cosine theta plus sin²θ. But this is over cosine. No, I did something wrong. So sine cosine plus sine over cosine divided. So, oh, multiplied by cosine over sine. Why did I say there is another cosine here, so this is cosine square. Right? Yeah, because I took this, which is that, and then I should multiply by sine over another cosine. I had a cosine as a common denominator and another one. Yeah, that makes sense. Over cosine square theta. Nope. I did something wrong, and I don't know what it is. Let me go back to this one. Cos square plus cos plus sine square. These two add up to 1. And this is cos. Cos square plus cos plus sine square. Yeah, this is correct. Sine plus tan over tan. Sine plus sine over cosine over sine over cosine. So sine cosine plus sine over cosine squared times sine. No. Let's do it again. Sine theta cosine theta plus sine theta over cosine theta. That's the numerator. And then you divide by sine. So you multiply by cos theta over sine theta. These cancel. And I can factor from here sine theta, yeah, that's it, times cos theta plus 1, because sine theta, if I factor it out, and I have in the denominator sine theta, and these will cancel, and you get 1 plus cos theta. I don't know what I was doing here. I think that's it. Maybe we can take the last one, just since we have a blank page here. Which one should we do? Last one? 29. Let's do it slowly. Over sine 2 theta plus 1 over tan theta equals secant theta cosecant theta. Okay, now I see that everything in theta except this guy. So I have to break it down. First, I say 2 sine, so I'm looking at the left-hand side. 2 sine square theta over 2 sine theta cos theta. Okay, right? 1 over 10 is cotan, which is cosine theta over sine theta. The 2 and the 2 cancel. Square with the sine cancel. So you get tan plus cotan, right? Or sine over cosine plus cosine over sine. So you take a common denominator of sine theta cos theta. This becomes sine square theta, and this becomes cos square theta, which is 1. So you get 1 over sine theta cos theta. 1 over sine is cosecant theta times 1 over cosine is secant theta, which is just the reverse of that. And that's, so all the identities, we know the right-hand side equals the left-hand side. So you pick one side and try to make it equal to the other. If they are too complicated, you can simplify one, simplify the other, and show that it's the same simplification. but don't do like me. Okay, work slowly and make sure you get everything right. Okay, so I hope you learn now everything about identities, double angle formulas, and half an angle. I think you get those in the sheet anyway, but it's nice to know them. So if you don't have the sheet nearby or available or at hand, you can just, if you know these, they simplify a lot of problems. Alrighty, so that leaves us with two more sessions. I will have one solving trig equations and one graphing trig functions, including transformations like translation, uh, dilation, and reflection. Okay? And until I see you then, I wish you all the best. And as usual, if you have any questions, please let me know and I'll try to get back to you as soon as I can. Thank you very much for watching. Sorry for the long session. Wish you all the best.